Hello, everyone. During JoSAA counseling, many students base their options of the various departments after hearing about this and that information from scattered bits or from some kind of unreliable information. Sometimes they use just pure guesswork to exercise their options. However, all this is not very good and helpful. So I thought it would be a good thing if we can get some proper, comprehensive, reliable information from proper, reliable sources. And what could be a more reliable source than the professors or the various departments? So here we have with us Professor Puneet Patra from the Department of Civil Engineering at IIT Kharagpur to discuss very important things regarding the discipline of civil engineering. So Puneet, a very warm welcome to you and thank you for joining this interview.
Thank you, Jeevanjyoti. Thank you. Thanks a lot.
All right. So Puneet, let us first discuss what is civil engineering all about and what are the broad areas or divisions within civil engineering.
Okay, thank you for this question. And once again, another big thank you for inviting me. The initiative that you have taken to empower our students before counseling is really, it's really a good initiative. And I hope that it benefits a lot of students, not just this year, but in future as well. So coming back to your question, what is civil engineering? Well, I will take a much more philosophical approach to answer this question of what is civil engineering. And I will take you back maybe 2000, 2005 years ago, when essentially you had two forms of engineering, in my opinion. Again, whatever I am saying is only based on my opinion. Okay. So we had just two forms of engineering, which was military engineering, and whatever that was not military engineering was civil engineering. And at that point of time, what constituted civil engineering per se was how to make the life of people easier. In other words, how to create homes, how to provide sanitation facilities, how to improve upon build upon the buildings, how to build the roads, and so on and so forth. Predominantly, civil engineering of this day primarily concerns development of infrastructure. Now, development of infrastructure in itself is a huge thing that is there. I mean, it starts from building of roads, building of bridges, building of ports, airports, building of factories, building of actual high-risers, right? So civil engineering in essence is basically one of the oldest form of engineering that actually helps us in improving our daily lives. And to be more specific, and if I have to answer you in a much more engineering term, it is basically concerned with creating new infrastructure. A major impetus of civil engineering these days is coming because of the focus of sustainability in the concepts of sustainability in engineering. All of us are aware of the issues of global warming, that the climate is changing, and how does that climate change or how does global warming affect all of us? To answer that question, we as civil engineers are increasingly looking forward to. Now, coming back to the major divisions of civil engineering. So depending upon the university to university or IIT to IIT or college to college, there may be some disparity with what I am saying, but predominantly there are five major sections of civil engineering: structural engineering, geotechnical engineering, transportation engineering, hydraulics and water resources engineering, and environmental engineering. Some of the IITs may have, or some of the other colleges may have construction engineering, which in some of the IITs may be subsumed under structural engineering domain. And some of the other IITs may have sections such as remote sensing, which is about which I will talk in a short while. So now coming to each of these disciplines, each of these sections of civil engineering, well, each of them play a significant role. And although they play an interlinked role, they can actually play a complete standalone role as well. For example, when we are looking into structural engineering, which is what I am a part of, we look into creating infrastructures such as your buildings, such as bridges, such as major ports, and so on and so forth. So anything in a very layman term, if I have to say, anything that you see above ground, any infrastructure facility above ground, that concerns structural engineering. Okay, so that in itself implies anything that is below ground. Again, in a very layman's term, it has to be taken with a caution. Anything with below the ground is a domain of geotechnical engineering, which predominantly deals with mechanics, dynamics of soils and foundations. It in itself is a very important domain. Just to give you an idea, let us say you have a ladder, okay, and you rest that ladder on the ground itself at the bottom and don't do anything at all, right? The ladder will slip eventually if you apply certain amount of load. So how can you prevent the ladder from slipping? Well, you can actually dig a hole around the base of the ladder and put some soil on top of it, or put some other material on top of it, which is what we do often, right? So in such a scenario, this strengthening of the base of any infrastructural facility, that in itself, in a very layman's term, concerns our geotechnical section. The other section, which is again very important, well, all 5 sections are very important, but again, one of the important aspects of creating infrastructure is to create your need to deal with the hydraulics and water resources. For example, let us say, again, this is an issue which we keep hearing, right? That the water table has gone down every year in our country significantly, right? So how do we efficiently manage our water resources? That is a question which is typically answered in our through our section called hydraulics and water resources engineering, where we look into things such as how does a river flow, what is the catchment area of a river, how can we efficiently manage water resources, how can we recharge water table, and so on and so forth. Not only that, let us say we are now trying to design the sewerage system of our, or pipe flow system or drinking water system of any of our cities, right? So we need to know how does this water movement occurs from the source to the end user, right? So all of this is taken care of by our hydraulics and water resources section. This also includes some very interesting domains such as dam engineering, which is a combination of structural as well as hydraulics and water resources engineering. Now, another important section of our civil engineering department is transportation engineering, which, as the name says, looks into how one can efficiently plan the transportation systems. This includes 2 different domains. One is related to pavement engineering, where we are looking into the creation of roads including low density roads and high density roads. Low density roads as in village roads are not so, not roads which are state highways or national highways. We also go for national highways, designing of national highways and state highways and other kind of highways. That is one side of the transportation engineering. The other side is traffic engineering, where we look into how we can actually plan the traffic within a city, or how we can control the traffic within a city. For example, let us say now I have to create an intersection where I have to properly plan where I can give the traffic lights, right? So it cannot be arbitrary. It has to be chosen through certain decision, right? What should be the speed limit on a specific stretch of a road? Again, it cannot be arbitrary. It has to be decided based through certain rational decision making. All of this is covered in our domain of traffic engineering. And last, perhaps the most important thing for the upcoming days is our environmental engineering domain, where, as the name suggests, we are looking into the different sectors which are quite polluting and how we can minimize the pollution. We deal with air pollution, we deal with water pollution, we deal with sustainable engineering, we deal with life cycle cost estimation of basically every activity that we do for creating infrastructure, right? So all of this is being studied through our environmental engineering domain.
I see. That was a bit of an eye-opener for me also. So I was actually not aware of certain things, especially what you mentioned regarding the traffic lights and things like that. I had wondered who does these things. So here is the answer. So very good to know. So now that we have such a broad overview of the various areas within civil engineering, could you perhaps throw some light on what kind of temperament people need to have in order to be suitable for this department, for civil engineering? I mean, general academic interests, general temperament, what kind of students should be considered to be a good fit in the civil engineering department?
So, civil engineering students, or rather a good civil engineering student, needs to have a blend, or rather an aptitude for both analytical as well as doing hands-on work, right? So analytical as in, there are certain courses which our civil engineering students have to take, which require the knowledge of mathematics and physics. So ideally, a student who is good in mathematics and physics should be able to do well in the analytical courses of civil engineering. But civil engineering in itself is not just limited to doing certain calculations in hand on pen and paper, right? One needs to have a feeling of getting things done with hand. So, for example, people get very much excited. Let's say I am a designer of some kind of an infrastructural facility. Just to give you a brief idea, I know of one of the professors of our department who had created an infrastructural facility which is used for rocket launching, right? So he then told me how excited he got when he could see the actual rockets flying from the ground till the space. So that feeling of excitement, right, of seeing the things which you have designed on the board getting created in real life, right? That passion has to be there amongst the civil engineering, and in order to have that passion, well, until and unless you go into that domain, you really do not know whether you have passion for that or not. So at this stage, when we are dealing with students of class 12th, or students who have just completed their class 12th, students who are interested in getting things done in a hands-on manner, let's say they are interested in creating small toy examples of something, real life infrastructure. So, Lego sets, right?
Yes.
People who are good with Lego sets, those who can be creative with Lego sets, I mean, that in itself is such kind of students would do.
They are on the same natural frequency as civil engineering.
Sorry?
They're at the same natural frequency as civil engineering.
Yes. So it is very fascinating. So you can see that there could be multiple different kinds of bridges, right? Some of them are aesthetically extremely pleasing, right? So any engineer who is creative enough to come up with such solutions, and that cannot happen overnight until and unless you, even though you have passion, that cannot happen overnight. That requires experience as well.
Absolutely.
Right. So how does that come? That comes if people are excited in doing things in a hands-on fashion. Okay.
So I'm guessing people also need to have a certain appreciation for geometry in order to be good.
Yes. So geometry have to be able to visualize things, not just to appreciate geometry. To be able to visualize things is a very important aspect of being a civil engineer. Not only that, I mean, I think it's a very important aspect of being an engineer.
Right.
So be it a mechanical or a civil or an aerospace engineer, we need to have the capability of visualizing things. So when it comes to civil engineering per se, let's say I have a building in a certain location to be planned in such a way. If I look from a different angle, how does that building look? How would the building look to me? Both on pen and paper as well as on computers, right? So this ability to visualize things, how they would look in 2D, especially because I mean we cannot make 3D drawings on computer or on pen and paper, right? So how can we perceive such 3D objects on two-dimensional plane, right? So that visualization capability is also quite. You are very much correct.
Right. So in the same vein, so when students are learning physics, chemistry, mathematics at the 10+2 level, they are naturally, I mean, some of them are naturally tilting towards certain topics. This happens with all of us. Some people may be more interested in the electromagnetic from physics. Maybe somebody is more interested in the optics side. Somebody is more interested in the algebra side of mathematics and this and that. So what do you think would be the topics that the students would have been interested in order to be a suitable match for civil engineering? Or if there is such a thing?
So I can just tell you from my example.
By the way, I'd just like to interject here. Professor Puneet Patra happens to be an ex-student, an ex-undergraduate student of our institute. So he's now a professor in the same department from which he graduated in. So mark these words with carefulness, what he's saying now.
So again, thank you for the kind words, Jeevanjyoti. So the topics in which I got very excited during my +2 days were mostly, in physics, it was mostly mechanics and thermodynamics. Okay. So what I see, and in mathematics, mathematics, every topic is important. You cannot say that one topic is less important than the other, right? So everything is linked as well, right? So it is very difficult for me to specifically narrow down on any specific topic of mathematics, which would be of use to civil engineering, because we in civil engineering use several different concepts of mathematics, especially when it comes to the analytical side of it. So I'll quote you certain examples on that in a short while. But when it comes to physics, I enjoyed the topics of mechanics and thermodynamics. And I see the concepts of mechanics are extremely important and used in our structural engineering domain. Right. So that is very, very much needed. So anyone who has an aptitude or who has a knack for mechanics would definitely be a good fit for our structural engineering domain. Thermodynamics, on the other hand, is quite important for domains such as environmental engineering, where they deal with a lot of things related to chemistry.
Right.
Also, for example, let's say I want to remove some kind of pollutant from water, right? One needs to know whether the removal, this entire process is thermodynamically feasible, how much energy needs to be supplied. Not only that, what kind of chemical reactions are occurring. So all of that a student needs to be familiar. Now, coming once again back to mechanics side, it is not just used in the structural engineering domain, because we have, as I was telling you, hydraulics and water resources engineering, which is the knowledge of fluid mechanics is quite essential. And again, that in JEE days, I remember studying a little bit of.
There was a chapter on fluid mechanics.
So having knowledge of mechanics is quite important, but that does not mean that if someone lies, let's say, optics, that is not important per se. For example, these days what is happening is people are designing the facade of the building with structural grade glasses, right? So that glass needs to have certain properties. It should not permit all the light, and otherwise it have greenhouse effects. So all kind of things are, a little bit of physics will be involved, and I think it will be needed for everyone. When it comes to chemistry, if someone is extremely enthusiastic about chemistry but likes to do civil engineering, I would say that, well, environmental engineering is quite full of the concepts of chemistry, and you would thoroughly enjoy.
Just excuse me. Sorry.
Yeah, that's okay. So, I hope I have been able to answer this question.
Yeah, I was actually going to ask you about chemistry, but you answered it yourself. So I was really not aware about it, that in environmental engineering side of civil engineering, you really have so much of chemistry.
Yeah, we do actually have quite a lot of chemistry.
I was wondering, perhaps, you guys work with a lot of structures which involve dealing with cement. And there also probably you need to have some knowledge of inorganic chemistry, if correct me if I'm wrong.
Yes. So basically concrete, which is, I'm sure all of us have seen concrete structures. So it's basically a bread and butter of civil engineers in our country, right? So concrete, the way the constituents of concrete are basically fine aggregates, which we commonly known as sand, coarse aggregates, which are gray colored, substantially larger size particles, and then we have water and cement. The way concrete gets its strength is because of the reaction of water with cement.
Yes.
Right. And just to give you an idea how the different domains of civil engineering are important, and they are also quite interlinked. So cement, as you will appreciate, is one of the most polluting industries of the world, right? If I am correct, around 7% of the global greenhouse gas emission comes from the cement sector, if I'm correct.
See, I was not aware of it.
I may be off by 1 or 2%, but if my memory serves correct, it's around 7%. So we are trying to come up with some kind of a substitute of cement. Well, we won't be able to replace cement completely, but maybe if we can replace 5% or 10% of the cement content, right, the entire process becomes greener. The entire infrastructure becomes greener than what it is right now, right? So in order to come up with a suitable substitute for cement, right, we need to know what kind of other materials are available. Right?
So this is something you are talking about at the absolute edge, cutting edge of the current research.
Exactly. The point which I am trying to impress upon is that if you look at it as in an isolation, making greener things is a domain of environmental engineering.
Right.
Making a concrete structure is a domain of structural engineering.
Right.
But this intersection, that we want to have greener infrastructure, which is what is the emphasis of civil engineers or the structural engineers across the world is.
Right.
So this intersection brings in the different domains of civil engineering and connects them together. So this is again equally important. So a good structural engineer needs to know a little bit of chemistry also.
Yes, yes, that is the take-home message from this. So talking about courses, now what kind of courses, fundamental courses students have to undergo, especially at the second year, third year level when they come into the department?
So as I was telling you that majorly we have 5 sections in our department. So typically the students have to take, so the course structure is typically split into core courses, core theory courses rather, and elective courses. So core theory courses come from all the 5 different sections. It is typically in most of the universities, most of the colleges, including IITs, the course structure is designed with an emphasis on structural engineering. And in structural engineering domain, one has to go through rigorous courses related to mechanics, which is solid mechanics, structural analysis, strength of materials, then how to code the stuff. So let's say I give you a framework of a building, and I tell you that this building is subjected to this kind of forces, right? Or this kind of loads. And I want to find out what are the internal forces in the building members, right? So if a building is too complicated, we cannot do it by hand. We have to take help of computers. Right. For that, at IIT Kharagpur, at least we have a specifically designed course for computer-based coding and computer-based analysis of such structures. Okay, so that is one side. We also have courses related to design. So once the student has appreciated what kind of internal forces are there in a structure, now they are capable enough to design the structure. So there could be 2 broad categories of structures. One could be concrete structure and another would be steel structures. So across the country, there are 2 important courses for structural engineering in around these. One revolves around the design of reinforced concrete structures and another revolves around the design of steel structures. Right. Apart from these courses, it is free for the students to take up certain electives from the structural engineering domain, depending upon their choice. It could be a course related to analytical methods. It could be a course related to more so computational methods, or it could be something related to advanced design also. Now, coming to the other sections, where, for example, if we look into hydraulics and water resources engineering, a student will need to take courses on fluid mechanics, water resources engineering, and the corresponding labs to that. Okay. Apart from these core courses, there would be elective courses in this domain as well. Likewise, in the geotechnical engineering domain, student needs to take course on soil dynamics, soil mechanics, soil dynamics, and foundation engineering. These would be the core courses. The names could differ depending upon which college a student is studying, but more or less, this is what is the content. When it comes to transportation engineering, the core courses revolve around, as I was telling you, there are 2 different distinct domains of transportation engineering. So we have 2 important courses. One is related to traffic engineering and another is related to pavement engineering. And lastly, from the environmental engineering domain, we would have courses on environmental engineering in general, and then we would have courses on your water and wastewater engineering, where we deal with water supplies, clean water supply at homes, how to design such systems, and how to take the sewerage from our homes to the corresponding facility where it gets treated, along with the design of such treatment plants. Apart from this, depending upon the choice of the student could take courses on air pollution, water pollution, life cycle cost estimation of our activities, so on and so forth. So these are the predominant core and elective courses. Apart from these, students have to take courses on surveying. Surveying is actually one of the most interesting and probably one of the most fun course to take, especially the surveying laboratory, where you get to actually measure the areas of a given patch of land, or you are asked to plot the map of the given patch of land, and basically it helps in planning, right, for the future courses.
So correct me if I'm wrong. So in quite a few of these courses, especially on the structure side, is it not perhaps true that there is quite a bit of application of matrices? Probably in the more broad way, speaking linear algebra.
So,
Okay.
so now
there again, you have the application of mathematics. So something which one would not nearly expect to have so much importance with some preliminary ideas, but ultimately it all links up together.
It all leads to that. That's why I was refraining from telling you which topics of mathematics would be very interesting, because we need the knowledge of matrices, the differential calculus, the integration, all those techniques.
Yes.
Again, all engineering domains require that. We require solution to ordinary differential equations, partial differential equations. So, it's very difficult to isolate one or two topics.
Exactly.
Probability statistics. That is
probability and statistics, right?
That's also very important. So
right.
Just to give the students an idea. So let us say I have some kind of an infrastructure facility. Let's say I have a building in itself, right? So that building has been designed keeping in mind that, look, the building will be occupied by so and so number of people, and it will be subjected to a wind of, let's say, 50 or 60 kilometers per hour, and it can take care of an earthquake of magnitude of 6.0 in Richter scale. What if something other than the design load occurs? That can very well happen. We have seen very recently the frequency of cyclones have increased, right? So let's say if not a wind of 50-60 kilometers per hour, the wind of 150 kilometers per hour strikes, right? So the building should be able to withstand that, right? But if we keep designing, if we design the building based on the idea that the building has to resist a wind speed of 200 or 250 kilometers per hour, that design itself would be very uneconomical. So that is where the concept of probability comes in two folds. First is to identify what kind of forces are going to come on the building. And secondly, how can I rationally design the building so that it is optimal, both economically as well as it suffices, it doesn't lead to, collapse as such.
Right. So really good to know these things. Okay, so we have talked about the various important courses and the interest that students may develop towards these courses. Now, on the flip side, students also have this doubt: how heavy will be the course load? So as a former student of the same department that you are now a professor, and on behalf of the entire discipline of civil engineering, could you perhaps give us some idea about it? How heavy is the course load in general?
So in general, I would say the course load would not be too heavy, except for a few courses which are actually difficult, that I would straight away tell you that it is going to be.
Actually, in all departments we have such courses, right? In all departments we have such courses, which are challenging, which are extremely challenging.
So I wouldn't name the courses though, because then it would be unfair to the respective course teachers, but yes, there would be maybe around 4 or 5 courses of the ones which I have listed would be quite difficult, quite challenging. But in most of the other courses, people will have fun learning. And remember, civil engineering, apart from the emphasis on the analytical side, as I was telling you earlier, there is also an emphasis on practical aspects, right? To have the things done with our hand. So such courses would be extremely fun to take, and they wouldn't be too loaded. But yes, certain analytical courses might be somewhat challenging. Overall, my experience was quite an enriching experience for me. I thoroughly enjoyed my stay here at IIT Kharagpur for the 4 years.
Right. So, so we can safely say that even after doing the coursework honestly and rigorously enough, it will still leave some time for the students to pursue their own interests in both in co-curricular as extracurricular activities, right?
So yes, I would say that students can and should explore apart from the academics. And our curriculum is well designed in such a manner that students will have enough flexibility to explore the co-curricular, extracurricular activities. Again, I do not have much experience of what is happening at other universities or other colleges, but from my own experience in my own college, I can say that we had ample time to explore our other interests. For example, just to give you an example, we did take part in inter-hall activities. I was a part of a few sports-related activities in my hall, which is the name for a hostel in
Kharagpur. Yes.
So students will get ample time, but then there is a flip side to it, and this is where I should caution the students that academics is quite important. At the end of their 4 years, they need to have a respectable CGPA, because that CGPA they will have to carry for the rest of their life, until and unless they become well-established professionals. So be it if they want to go for higher studies such as master's courses, whether in India or outside, or whether they want to pursue their PhD studies, or whether and if they want to pursue their MBA within India or outside, CGPA, having a respectable CGPA is a must.
Yes, we cannot emphasize that enough. We cannot emphasize that enough. And
So
people should remember, like, which one is the curricular and which one is the extracurricular. They
word
should
extra.
Yeah, the emphasis is on the extra.
So that needs to, I don't know, as you were saying, that how much to emphasize upon this, because that is, see, what happens is sometimes in one of the semester might be a bit too loaded than the another semester. That is how the curriculum is typically designed. So in the not so loaded semester, students get engrossed in other extra academic activities too much, because of which their current academics in that semester starts to not work that well. So that kind of a situation should be avoided. But in general, most of the curriculum across the country is designed in such a way that students will have ample time to explore their interests.
Right. That's good to know. So now, moving on from the coursework to the exit stage. So, what kind of core jobs are there available for civil engineers, and are these available in India?
So core jobs are actually, they are available in India, not just available in India. Industry partners, when we talk to, they are actually looking for some good civil engineers. They always say that we cannot have enough good civil engineers. So core jobs, by core jobs, I mean jobs in the construction sector, jobs dealing with designing and analysis of infrastructural systems, jobs related to your water resources engineering, such as ones which we go for designing the pipelines or plan the water resources, the hydraulic resources around the country, jobs involving our environmental domain. In fact, there are some up and coming startups which are also looking for very good civil engineers. right? Such kind of jobs involve state-of-the-art technology such as 3D concrete printing, right? So there are ample jobs. I cannot emphasize upon that. And these jobs are extremely important and are available in our country, and not just available, they are important for our country also, such kind of jobs. And they are also available across the world. So yes, job-wise, there should not be any significant concern for the students. But there is a caveat I will give over here, that civil engineering as a profession, if you expect that on the first day itself you will be earning, I don't know, 30, 40, 50 lakhs as a fresh graduate engineer, that would not happen. So to be a good civil engineer who is a practicing engineer, you need to devote certain amount of time. So I have seen exponential rise in the profile of our graduates, those who have decided to continue with civil engineering domain across a long period of time, across maybe 8, 9, 10 years, and then they have an exponential rise. But to have the expectation that on the first day or the first year itself, I will be having, 35, 40 lakhs worth of job, that may most likely will not happen in the
I
course.
think this is an extremely important caveat that you have put forward. People need to calibrate their expectations and need to have a proper realization of the growth trajectory that is there in different disciplines.
Exactly.
For example, in certain disciplines, maybe in the circuitral branches, let's be honest about it, maybe at the entry stage itself, the pay package is quite high. But then one also has to remember that those are relatively younger disciplines. The discipline itself is younger. So a 4-year graduate would immediately have something concrete to contribute in those disciplines and the jobs of those disciplines, compared to an engineer, a fresh graduate in mechanical, civil, aerospace, because these are disciplines which are extremely old, like more than a century old, and for civil engineering, like thousands of years old. So there is a knowledge base over which one has to stand, and a fresh graduate cannot be expected to contribute at that level headlong. So
Yeah.
one has to give one's dues in the discipline, and only then start getting the return back from that.
Exactly. So the more experience you get in such core engineering domains, right? So the more phenomenal rise you are going to have in your profile. So so we can, I mean, if you may permit me, I can say that our professions the core engineers their professions are more like that of a doctor. The more experience a doctor is, the more earning potential that doctor has.
Exactly.
Right?
Exactly.
So on day zero, on day first, one should not join civil engineering with the expectation, or in fact, any core engineering with the expectation that they are going to have a stellar pay package just after leaving the.
And civil engineering is such a profession where people's lives are at stake. When you build a bridge and it breaks down, it kills people. When you make a website or even some kind of a banking system, if it fails, yes, it causes a lot of hardship to people, but it doesn't kill anyone right away.
What is even more fascinating is whatever you see around you, right?
Yes.
There has been a contribution of a civil engineer.
Exactly.
The room where you are sitting, be it the factory where your laptop or your mobile has been manufactured, be it the road on which you have traveled from your home to office, or to your home, from your home to your school or college. So everywhere you see a contribution of a civil engineer.
Yes.
Right? So as I was telling you earlier, right?
So without civil engineers, the whole country will break down. No matter which country it is simply going to break down.
I would go one step further, and I would say that civilization would break down. Not just a country, the entire civilization.
Yes, true. Absolutely true. Even though I'm a mechanical engineer, I have to admit this. So hats off to you guys. So now let's talk a little bit about the future prospects on the terms on the side of higher studies. So you have yourself had a very stellar record in higher studies, and you're doing very well now. So students, please note his words very carefully. And you could perhaps also give some idea about the offbeat kind of tracks that civil engineering graduates can pursue. So some of the work that you do, probably someone without the know-how would probably think that this is physics or physical chemistry or something like that. So give us some idea about it, please.
I will try to be as simple as possible. So to answer your first question, I would like to just quote you certain numbers. Again, this is a number which I have found out, and it may not be true for a larger. Okay.
Right.
So out of all the students, I think on whatever little that I have had experience over here teaching, around 5 to 10% of the students go for higher studies in the core domain. Likewise, 10%, 10 to 15% of the students go for core jobs.
Right.
Okay? Around 5 to 6% of the students go for UPSC or IES. I mean, engineering services,
Yes.
right? In fact, it gives me very, I mean, I'm very happy to tell you that few of my batchmates are right now in such engineering and administrative services. Okay.
Right.
So when it comes to
unfortunately, these kinds of news never makes it to the news.
So, and a significant portion of our students also go for consulting domain and other the traditional route that which the students are now taking, which is product engineering and software engineering roles. So I'm not very familiar with those, so I cannot speak much about it. So coming to the research-based question which you had asked, well, the prospect of research in civil engineering, to be more specific, is huge. I mean, it's extremely huge. As I was telling you, one example where we are trying to make a suitable substitute, we are trying to find a suitable substitute for cement, right? That is not a problem which is relevant to India. That is a problem relevant across the world.
Right.
So people across the world, researchers across the world are trying to find such kind of solution. Researchers across the world are trying to come up with more more sustainable form of infrastructure across the world. So just to give you an idea, so let's say I have a building and that building is made up of concrete. So a building will have definitely certain lifespan. It could be 60 years, it could be 80 years, 100 years, whatever, right? So after the lifespan, the building has to be demolished. What do you do with the demolition waste, right? So can we use that to create new kind of infrastructure?
I see.
Such kind of questions are being asked across the world. Take the case of our steel industry, where we produce what is known as slag, or take the case of our coal-fired power plants, which also produces fly ash, right? So can we make use of these slag and fly ash in coming up with new kind of engineering solutions? So such kind of questions are being explored. Now, apart from this, people are looking into how one can go for, again, this is a problem relevant across the world, with the propensity of flooding, flash flooding increasing, right? So can we develop solutions so that our infrastructure doesn't get washed away under such severe flash flooding? So these are another important. This is another important aspect of civil engineering, where people are trying to find a solution. When it comes to me, my work is well linked, but yet not linked. So I just to give you a very brief idea about what I do. So basically, the inspiration of my work comes from the principle that, or from the statement of Richard Feynman, that there is plenty of room at bottom. So this is a very old statement and very popular statement made by Nobel laureate Richard Feynman. So the work which I do is basically revolving around nanoscale systems. Right. So to give you a very brief idea, so let's say if I have a fracture, if I have a crack, right? So in simple terms, what I observe as crack in a material with my own two eyes, that crack is occurring at a very large scale. Effectively, that crack has occurred because of certain bonds between two materials getting broken, or two atoms or two molecules getting broken, right? So how does the breakage of bonds at such atomic scale level eventually manifests in a crack that we can perceive with our own eyes. So such kind of problems is something which we deal with. And we make extensively use of, although it sounds very complicated, and we are dealing with dynamics of systems at atomic scale. In very simplistic way, if I say, we are actually solving nothing but Newton's laws of motion.
Yes, you are repeatedly solving Newton's laws of motion like billions of times.
Yes, Newton's laws of motion billions of times. That is where my research.
That is effectively what you do all day in your research. Putting it very simply.
Putting it very simply.
Yes.
So it's very interesting, and this is where we as civil engineers can.
The complication starts when you have to agglomerate the results from all those billions of equations in a statistical mechanical sense.
A statistical mechanical sense. So we need extremely good computational resources.
Right.
We need actually the capability to do programming, not just serial programming, but multi-threaded programming. We need the ability to analyze, hundreds of GBs of data.
Right.
So it's a combination of a lot of things. So anyway, some of my students are really doing good. So I'm really happy about them as well.
Right. Thanks a lot for touching upon it. So talking about huge amounts of data, how can we not discuss data science, artificial intelligence, and machine learning? So let's not get into the side where artificial intelligence is being utilized in the research domain, because no matter what the engineering discipline or scientific discipline, there is a huge influence of artificial intelligence and machine learning on that. We know that and we acknowledge that, but perhaps for far more immediate interest to the students as they're about to choose their departments, would be the question regarding the influence of artificial intelligence and machine learning on the kind of core jobs that are there in this discipline. What effect would AI and ML have on this side of things?
So AI and ML, in my opinion, would definitely impact all the different engineering domains when it comes to the actual job market. That will happen, but it will never replace a human engineer. It should be able to supplement human knowledge, but it should not be, at least in my perspective, it wouldn't be able to replace an actual engineer. That is because, let's say, AI is extremely good at recognizing patterns, right? So when it comes to civil engineering explicitly, so even though we have some broad commonalities, you can see that everything is quite unique. So if I take the example of two bridges, you would perhaps understand the differences. Yes. Howrah Bridge is completely different from the Kolaghat Bridge, which we have nearby, which yes. Most of the people might not have seen. But it is also completely different from the Bandra-Worli sea link that is there in Mumbai, right? Yes. So until and unless we have the commonality, AI will not be able to replace the role of a human, right? So human engineers would be needed when it comes to civil engineering, because the challenges that we are facing when coming up designing an infrastructure is unique to a specific area. It is unique to a specific, not just area, it is unique to a specific problem that we are trying to address. Okay, so but in an ideal situation, a student needs to have a basic knowledge of the tools of not just AI/ML but also data analytics. In the sense that when a student is opting for a course of civil engineering in any university, they need to be able to see the curriculum and check whether there are enough opportunities for the student to learn the basic concepts of AI/ML, data analytics, because they are going to be indispensable. Even though they might just supplement the role of an engineer, but having knowledge of such AI/ML tools would be very, very beneficial for the students.
So to put it simply, they certainly need to have their core expertise in place. But in addition to that, they also need to have specialized knowledge in these domains too. in order to be suitable for the third decade, fourth decade, fifth decades of the 21st century.
Exactly. Because some of the roles might become redundant. We cannot predict 3 years, 30 years from now, right? Some of the roles might become redundant. But to my limited understanding, the role of an engineer would never be completely replaced by an artificial intelligence, at least.
Right. So talking about, so you had briefly mentioned regarding the taking a look at the curriculum, which brings to mind the question. So suppose a student is considering to whether to join civil engineering or not join civil engineering, and then the question becomes which institute to go into, these kinds of things. So these are very sensitive issues. So what would be your advice regarding this? So would it be necessary perhaps to check the kind of infrastructural facilities that the department has, so that a comprehensive education can be given? So something along this lines, if you can please elaborate.
Yes. So this is a very important question which you have asked, and this is where I see a lot of scope for the students to exercise their own judgment in a much more careful manner. So typically what I have observed is that students have decided to join some XYZ course, be it civil engineering or any other course, based on the record of the previous year.
Previous year's ranks.
Or previous year's ranks, or based on the funda received from their seniors.
Right.
That's one source of information, and the second source of information is the placement statistics which come out, right?
Yes.
These are the two things with which students typically make the decision. In my opinion, that is not the right way to go for. Okay, I'll be very blunt about it. That's not the right way to go for, because a student needs to. This is an most important perhaps career decision a student will take, right? So they need to be on the lookout for other more important markers. Most important of which would be what kind of an education a student is getting if the student joins XYZ engineering discipline and ABC college.
Right.
There they need to look into I'm just talking about in general engineering, not just civil engineering, because some of the things I believe are important, not just for civil engineering, for other engineering domains as well.
What you're going to say is absolutely true for mechanical engineering, aerospace engineering, wherever you have the necessity of big infrastructure. Yeah.
Exactly. So a student should look into the graduates of the corresponding department which they want to join, and the university which they want to join. Not the recent graduates who have, who have obtained their degree maybe 10 years ago, 15 years ago, and see what they are doing, what kind of jobs they are doing right now. Because then they can see that 10 years down the line, what kind of jobs they would expect if they had taken such kind of a career trajectory. Right? So that is one very important source of information which students need to look through. There are several resources which students can, from which the students can get this information. And I implore the students to explore about such resources. That is one important thing. Second is what kind of education the student is getting received from their college, in the sense that what kind of professors are teaching in the corresponding department of the corresponding university. In an ideal situation, a professor should be, they should be able to impart a holistic knowledge, but whether that is being done or not, that we cannot tell, right? So they should look into the curriculum of the department of the university they want to join in such a manner that an holistic education is provided to them. The holistic education incorporates not only the explicit engineering courses that we have discussed, elements of data analytics, elements of artificial intelligence, machine learning, courses on mathematics, courses on humanities. They will help the student to grow up as a mature individual. And pertaining to core sector per se, or core engineering per se, my advice to the students would be to explore whether a specific department of a specific university has certain equipment or not, is equipped enough, their laboratory facilities are equipped enough for them to give them a hands-on experience to what is going to happen in the field. Because when we talk about creating infrastructure in civil engineering, or when we talk about creating some kind of machines when it comes to mechanical engineering, we need to have, or the students need to at least have been able to get exposed to those important infrastructural facilities or machines in their own laboratory of their own university and the department. That is very much needed. So that students need to explore more.
Yes, so from my side, I have already mentioned this in my previous videos. So when it comes to core engineering, probably it is a little safe if you go to a more established college where there is an established history of imparting education involving all the various equipments which are fundamental to the discipline.
Yes. So the chances of things going wrong is less, more
Yes.
established.
Yes, because they have survived time.
They have survived times. Yeah.
Right. So beyond the core expertise, beyond artificial intelligence and machine learning and all these things, what would be your message and advice to students who are joining civil engineering? And by the next week or couple of weeks, students will perhaps know for sure whether they would be joining civil engineering. What would be your message to such students? How they can be on the lookout to develop their faculties beyond the coursework? For example, something as simple and straightforward but very essential is interpersonal skill, because no engineer works alone. They have to talk with other engineers, they have to talk with scientists, they have to talk with clients. And this is just an example. So what kind of things on the other side do you think students should develop?
But apart from the usual courses in which they have to do well for excelling as a civil engineer, as you have really pointed out, that interpersonal skills are very much needed for being a good civil engineer. How can one do that? How can one develop that? Well, the simplest suggestion which I can provide at this moment is to have healthy debates around topics with their friends who will be residing besides them in the next 2-3 months. I mean, that is how we have learned when we were undergrad students here at KJP. We had learned so much by debating and talking amongst our friends about different issues. It could be societal issues, it could be economic issues, it could be anything basically that interests you. In fact, I remember one of the students, one of my batchmates, was extremely good at computer programming, and he also taught us how to create video games. Right. So we those knowledge may not be. You may think that creating video games, how would it help me as a civil engineer? Right. You never know how it would help you. So be on the lookout of new knowledge. You never know when it would be utilized. So that is the simple message that I will give, that always be receptive. Don't close off your mind. Always be receptive to the new ideas. Be open and acceptable and be ready to accept newer ideas. Have healthy debates amongst your friends. Talk amongst your friends on the new topics, on the new things which are happening across the country, across your state, across the world. And that will help you in appreciating a lot of new stuff and will actually help you in becoming not just a good human being, but a good engineer as well as a good civil engineer.
Thank you, Puneet, for the wonderful message. And with that, let us wrap this up. It has been wonderful talking to you. And on certain points, even I was not aware of certain things. So thanks for opening my eyes, as I'm sure the students would be thanking you for opening their eyes. And I hope students would be able to make a proper informed decision after looking at this video. So thank you once again, and all the very best to the students who would be joining this wonderful ancient discipline of civil engineering. Thank you.
Thank you, Professor Jeevan Jyoti, and all the best, students. I'm pretty sure and I hope that you will do very well. Thank you.
Thank you.